Good afternoon to you. Mark Sudduth, HurricaneTrack.com here with your Hurricane Pro and HD video blog for the 6th day of July 2013. So glad you could join me this afternoon. Hey, I'm trying some new annotation software to mark up and draw on these different images. Now I can use web pages and satellite animations instead of just PowerPoint with static images. So bear with me. Hopefully I can get through things nice and smoothly on today's video blog for you. First, before we take a look at the Atlantic Basin, which is starting to percolate a little bit, let's begin in the eastern Pacific where things are still very active. We still have Tropical Storm Delilah here. Actually, it's a depression now, so it's weakened down to a depression, losing its convective activity, and so it has been downgraded to Tropical Depression Delilah. Then we still have Hurricane Eric sitting in here, and let's just mouse over this and check out the very latest. Okay, this is still their 11 o'clock East Pacific time advisory info. 80-mile-per-hour hurricane at the time. This will be updated shortly, and you can track it right there in Hurricane Pro or Hurricane HD. Looking at a satellite picture of this area, let's go to the Eastern Pacific visible satellite animation, and you can see why Delilah was downgraded. Most of the convection associated with it starting to die away a little bit. We'll zoom in just a hair to this particular shot. There we go. That'll help clarify things. Minimal convection mainly on the western side of the circulation center. Overall starting to weaken. I always am fascinated by how these systems affect this cold water cloud deck, this stratocumulus layer that sits out over the eastern Pacific, and these low pressure circulations move in there and have an interesting impact on the shape of the cloud field that's already out there because of all that cold water that lies over most of the eastern Pacific. Not down here in the tropics, though. Things are pretty warm, and therefore you get these hurricanes like Eric right here. Very well-defined banding structure associated with it. A pretty solid eye wall forming right in here. Luckily, it's pretty small as well, so the worst effects are staying just off the coast of Mexico, and that's keeping the highest wind and the rainfall off the coast. Another interesting note, you can tell that the southern part of the storm, the hurricane here, is more robust than is the northern part, and I think part of that reason is because of the wind flow, the circulation coming across Mexico here and getting jammed up by some of this orographic lifting, disrupting the low-level inflow just enough to keep this from really gaining strength. When they're that close to land, they typically have a difficult time intensifying rapidly, no matter how warm the water is. Alright, so let's take a look at the future of Eric. That's the most concerning feature right now. The forecast track, at least as of 11 o'clock Eastern, Pacific time, I keep forgetting that, shows that maybe getting closer to the coast of Mexico here to Puerto Vallarta, and then eventually turning off to the northwest here, away from land. How soon it does so to try to avoid a strike on Cabo San Lucas or La Paz and the southern end of the Baja will remain to be seen. A lot will have to do with how strong it gets and what the upper level winds and steering patterns are to the north, whether or not this high can build in enough to steer it off to the west sooner. We'll just have to wait and see. One of the forecast tools we have, of course, is the computer models. Interesting with the GFDL, that's the pink line that I'm going to draw on in red right here. It shows it getting up into the Gulf of California and then cutting across the southern part of the Baja Peninsula. So we'll have to wait and see if that actually happens. Some of the other models we can look at here, the LGEM, the green one is the beta and advection shallow. That's more useful for something like Delilah, which is losing its tropical thunderstorm activity. The orange one here is the climatology and persistence, or CLIPER, but you can see that a good deal of the models, just looking at a clustering of them, have it turning just enough here to the south of Cabo San Lucas as I color it all into red there. Only the GFDL really is the outlier. Maybe one other one. Let's see what that one is. Mouse over it. That's the H-Wharf, of course. I should have known. The H-Wharf and the GFDL usually like to look at things with the same perspective, it seems. But the majority of the models, though, do carry this away from Cabo San Lucas, and we'll have to hope that will come to pass. Now, let's go back to the National Hurricane Center homepage as our starting page here, if this will come up. And we can look at the Atlantic Basin. Yes, there's a couple of areas of interest. One is in the Gulf of Mexico, 10% chance of development. The other one, 30%, a strong tropical wave sitting out in the eastern Atlantic. First of all, let's take a look. This is the Gulf of Mexico disturbance, so why don't we take a look at the Gulf? And we'll put this into motion for you. This is an infrared satellite shot, which shows you the cloud temperatures, the cloud top temperatures. And the whiter, more bright white they are, the higher up they are in the atmosphere. Now you look at this and you might say, wow, it really looks like a lot going on down there. Well, there is and there isn't. There's surface troughs draped across this region, which is like a little focusing mechanism. The energy, though, is spread out over quite a long area. The vorticity, or the spin, and I'll show you that in just a moment. The more concentrated area might be down here, but it's not amounting to much. It's going to basically just send a lot of moisture back up into areas, especially the Florida Panhandle, that could just say, hey, forget it, we don't need any more. I was hoping we could get some over to Texas where you could use the rain, and maybe there'll be a few scattered showers, but a vast amount of this moisture and energy is going to come up into the central Gulf Coast, and I think this will do so without much fanfare. In other words, I don't see this developing much, excuse me, more than it is now. And that's good news, right? Especially since you don't need any more rainfall along the western Florida Panhandle, that is for sure. So let's go back out to the satellite menu, and let's take a look at what's going on in the Atlantic, tropical Atlantic anyway. Way out off the coast of Africa, a vigorous tropical wave came off the coast a couple of days ago. This is the Cape Verde Islands right here, and here is our area. This is actually Invest 95L. Remember, they designate these 90 through 99, these suspect areas, when they get enough attention, or warrant the attention, I should say, and they get the letter L for Atlantic. Rather small envelope of energy associated with it, and you can tell even by this satellite picture that there's some drier, more stable air to the north. And in fact, if we go and look at that on a satellite shot, this is the University of Wisconsin's Saharan air layer analysis tool, and all of this right here is your Saharan air layer, that dry, stable, in many cases dust-laden air. But look, there's the little system right there to the south of all of that dry, stable air. In fact, I did a little zoom-in slide for you. Check it out. That's 10 degrees of latitude right there, and here is our tropical disturbance, our tropical low, just to the south of all of this very hostile dry air. Now it's interesting that even though it's there pretty far to the south in latitude, some of the computer models, if we go look at the models for this system, do indicate that it should gain some latitude. In other words, it should start turning more to the west-northwest here over time and head generally in the direction of the Lesser Antilles. Now this is if it survives. All right, I don't know that necessarily it will. I think it's got, well, it says 30% chance over the next 48 hours. But the long-term prognosis, it's really tough to get something to develop this far east this time of year. And typically, if something hasn't developed by the time it reaches the Caribbean Sea here, it generally won't develop. And the reason for that is more complex to explain, but this region is usually kind of like a graveyard. If they don't develop by the time they get there, they usually have to wait until later to do so. Now, one of the things that I wanted to show you, let me go to my vorticity shot here. This is really interesting. This shows the amount of spin in the atmosphere, and in this case it's at the 850 millibar level, or 5,000 feet up in the atmosphere. Here in the eastern Pacific, this is Delilah. Still has a decent amount of spin, but not much energy, not much vorticity. The higher up on the chart we go over here on the right hand side, the more vorticity or spin there is in the atmosphere. And what I like to look for in the tropics with these storm systems, hurricanes, tropical storms, tropical cyclone being the generic term, is the shape, the roundness. And the more round one of these vorticity areas is, typically the stronger it is, because the energy is being focused. We call it the conservation of angular momentum. And the more round something is as it is spinning, its shape, the more efficient it is at that vorticity or spin. Think about an ice skater spinning around on one skate. The faster they spin, they're pulling their arms in, they're conserving that energy, focusing it around a common center, and that's what we have here as a great example of that in the Eastern Pacific, with a weakening tropical cyclone here, still decent vorticity, albeit starting to weaken a little bit, and then a stronger area of vorticity or spin associated with Eric. In the Gulf of Mexico, remember I mentioned the energy is spread out over a larger area. There is a little bit of a concentration right there, but probably not enough for this to amount to anything. And then out here in the eastern Atlantic, there's the area of vorticity associated with 95L. It too kind of stretched out, not quite focused yet, although this is something we can watch over the next several days. And if it can gain some of that vorticity and start to look more like this, then it might have a shot as it comes into somewhere in this window over the next several days, passing probably through the Lesser Antilles here. So regardless of development, it's probably, I would say, almost a certainty with this much moisture and energy out here now that this will bring inclement weather to the Lesser Antilles over the next several days. Showers and thunderstorms and an increase in gusty winds through that area. Beyond that time, we'll just have to wait and see what happens as to whether or not this develops further, if and when it can make it into the Caribbean Sea. So there you go. Things are starting to pick up. We thought they were as that MJO pulse, the Madden-Julian oscillation, which is your period of more favorable upward motion and enhanced tropical convection, moves into the Atlantic Basin. We were talking about that quite often over the last 10 to 14 days, and now it's starting to come to fruition. How much it impacts the tropics and whether or not we get anything to fully develop, well, you have to stick around to find out. It's an ongoing story, as is always the case, right? Have yourselves a good rest of your Saturday. Again, I'm Mark Sudduth for HurricaneTrack.com. Hey, I got through that new annotation stuff and my different presentation method pretty well today. I'm happy with that. I'll have more for you tomorrow.